Assalamu alaikum everyone. I hope everyone is fine. So today we are going to start a new lecture. So our topic is Fourier series. So now what we will do in this lecture, so we'll find the constant terms in the Fourier series. So that is the main task in this lecture. So how to find the constant terms in the Fourier series. So we are not going to write the whole Fourier series, because what is more important in your engineering problem, so you have to find many times constant terms in the Fourier series. So that we'll study how you can find the constant terms. So what are the constant terms in the Fourier series? So the constant terms in the Fourier series, first one is A naught, where the formula is 1 over L integral from 0 to L f of x dx, where L is a length which vary and your x, this x varies from 0 to L. 0 is less than or equal to x and x is less than or equal to L. So L is that length, and then an the formula is 2o divided by L and integral from 0 to L f of x cosine of 2 pi n x divided by L and then dx. And similarly bn, it is same as nan, but instead of cosine there is sine, otherwise the formula is same. So you have to remember these three formulas, a naught, an, bn, and then you can solve this integral. You can find the values of a naught, an and bn. Now I will move to the question. Now your question is, look at the function f of x, x for x varies from 0 to 1, and 2 minus x for x varies from 1 to 2, and 0 otherwise. Now the question is, find a naught, an and bn. So these were the constant terms in the Fourier series. So we have to find an, we have to find a naught, and we have to find bn. Now here you can see our function is given as piecewise defined function, where your f of x is x between 0 and 1, and then from 1 to 2 it is 2 minus x, and otherwise it is 0. Now you can see here your x varies from 0 to 2. So your it means your L will be 2, because we said your x will be varying from 0 to L. So it means in that case your L is 2. So now we will find one by one. Now since we know the formula a naught, which is equal to 1 over L, 0 to L f of x dx, so the value of L is 2, as I said before. So that is because x varies from 0 to L, so highest value in the interval is 2, so L is 2. So it means 1 over L, 0 to L f of x dx, that will be equal to 1 over L is 2 to 0 to 2 f of x dx. Now 0 to 2 function, direct function is not given, because this is a piecewise defined function. So your function, you can see it is given from x 0 to 1 and then 1 to 2. So it means first we will break this function into integral into 2. So we will write 0 to 1 and then 1 to 2. Why have we have written this? Because there was no function given from 0 to 2, because one function is given from 0 to 1 and the other function is given from 1 to 2. So 0 to 1 your function is given as x, and 1 to 2 your function is given as 2 minus x. You can see when x varies from 0 to 1 your function is given as x, and when x varies from 1 to 2 your function is given as 2 minus x, and otherwise 0. So otherwise then we will not write. So now next we have to solve this integration problem. You know the integration of x is x squared by 2, and then the integration of 2 is 2x minus integration of x is x squared by 2, and you can substitute the limit from 0 to 1 and then 1 to 2. You can simplify this. I will not explain, because this is very simple. You will solve many times these integration problem. So if you simplify, you will end up with 1 over 2. So this is the value of a naught. So now we will find an. Now to find an, The formula is 2 by L, 0 to L f of x cosine 2 pi nx divided by L dx. Now we know L, so we substitute the value of L here. So it is 2 by 2, 0 to 2 f of x cosine 2 pi nx divided by 2 and dx. This 2 and this 2 will cancel. So we will end up with 0 to 2 f of x cosine pi n x, because this 2 to cancel, so it is left cosine pi nx. Now again, your function f of x is not given from 0 to 2, but it is given from 0 to 1 and then 1 to 2. So again we will break this integral. So we will write 0 to 1 f of x and then plus 1 to 2 f of x cosine n pi x dx. Now 0 to 1 your function is given as x. So we will change f of x with x, and 1 to 2 your function is given as 2 minus x. Now you can see here x cosine pi and x dx. So we cannot solve this question directly. We don't have any formula for integration for this integral to solve. So we know this we can solve by using integration by parts. So there are two function given. One is x and the other one is cosine pi and x. And similarly for this integral, again we have to use integration by parts formula. So here 2 minus x is one function and the other function is given as cosine pi n x. So you can use the integration by parts formula. So first we can solve 0 to 1 x cosine pi n x dx. Now for that there are two ways to solve this. One, you can use the long integration formula. The other way, you can use the tabular method, tabular form. So the tabular method is in these question, I think I will recommend that. That is very easy to use, because if this will be your u function. If I call a u function as x, and v is your the second function, which is cosine pi n x. So how we choose this? So we choose u that function where that will take after, if we take derivative of this function, after some derivative then it will give 0, because if I take derivative of x it is 1, then again derivative of 1 it will be 0. But if I take cosine as u, then this function will never finish, because you know the derivative of cosine is then minus sign, then again derivative of minus sign will be minus cosine, and so on. So this will never finish. So only this function x can finish. So it means I will take u as x and v as cosine pi n x. So what I will do now, I will take derivative of this, and here I will take integration. So this is the method in tabular method you use. So derivative of x is 1, and then again the derivative of 1 is 0. So you will stop here. Now the integration of cosine pi n x, you know integration of cosine is sine. So cosine ax, we know the integration of cosine ax is sine ax divided by a. So here your a is pi n, so it means it will be sine pi n x divided by pi n. And again integration of sine pi n x over pi n, so integration of sine will be minus cosine pi n x, again you will divide with pi n, so this will become pi square n square. Okay, and then you will here put this arrow again here. So you will start here with plus, minus, then it will go plus, minus, like this. Now you multiply x with this. So it means x, you will not add this. This will only serve for sine. So x multiply with this. So it means this will be x sine pi n x divided by pi, plus 1 multiply with this. So minus and minus will become plus. So this will be cosine pi n x over pi square n square. So it means integration of x cosine pi n x is x sine pi n x divided by pi n plus cosine pi n x divided by pi square n square, and your limit is from 0 to 1. Now I will substitute upper limit here 1 in x. So it means this 1 sine pi n 1 divided by pi n plus cosine pi n 1 divided by pi square n square, minus, you will substitute the lower limit 0. If I put 0 here in x, so 0 multiply this all will be 0, plus cosine pi n 0, so this will be cosine 0 divided by pi square n square. Now, so this will be equal to sine n pi divided by n pi plus cosine n pi divided by pi square n square, minus cosine 0 divided by pi square n square. Now note that cosine n pi is 1 if n is even. So you can find this value easily. For example, if I put here n say 2, okay, we said if n is even, if you put n 2, so it will be cosine 2 pi. Cosine 2 pi will be 1. If you put say here 4, so cosine 4 pi will be 1, cosine 6 pi will be 1, cosine 8 pi will be 1. And if n is odd, so it means if I put here 1, so it means cosine pi it is minus 1, cosine 3 pi will be minus 1, cosine 5 pi will be minus 1, and so on. And if cosine n pi, if it is not known that it is even or odd, so it means then it will be cosine n pi will be equal to minus 1 power n. Why minus 1 power n? Because if you put here n1, so it will be cosine pi. The value of cosine pi is minus 1. If you put n2, it will be cosine 2 pi, so it will be plus 1. And now you can see here minus 1 power 2, it will be plus 1. And minus 1 power 1, it is minus 1. So that is why we are saying cosine n pi for all values of n, so it will be minus 1 power n. And so I can find any value. If I want to find cosine 3 pi, 4 pi, 6 pi, so I can use this formula. And then the value of sine n pi will be 0 for all n, because if you put any n here, n1, cosine sine pi 0, sine 2 pi 0, sine 3 pi 0, sine 4 pi 0. So for every value of n, so this will be equal to 0. You can use your calculator, but your calculator must be in radian when you are finding these values. So it means if you use this technique, so sine n pi it will be 0. So 0 divided by n pi, so this will be 0. Cosine n pi will be minus 1 power n divided by pi n square pi square minus cosine 0 is 1. So it is 1 over n square pi square. Now if you combine this, so it will be, because this n square pi square denominator is same, so we can write minus 1 power n minus 1. So this is your value of first integral. Now similarly we can now we solve only this integral. Now we have to solve also this second one integral. Now if we solve the second one integral, now we will solve the second integral. So it is from 1 to 2, 2 minus x cosine n pi x dx. Again you have to use integration by parts formula here. So you will choose u as 2 minus x and v as cosine n pi x, because we know why we choose this u, because if I take derivative of this function, it will finish, because derivative of 2 minus x is minus 1, and then the derivative of minus 1 will be 0. And the integration of again cosine n pi x is sine n pi x divided by n pi. Again integration of sine will be minus cosine n pi, and again n pi will multiply with this, so this will be n square pi square. Again you can join these, so you will start plus minus and so on. So you multiply 2 minus x with this, so you will get 2 minus x sine n pi x over n pi, and minus into minus is plus, plus into minus is minus, so it will come minus, and then 1 multiply this, so it will be cosine n pi x divided by n square pi square. I have written here this, and then I substitute this value here. Now you can substitute the limit from 1 to 2. Now if you substitute here 2, so you know 2 minus 2, it will be 0. So 0 multiplied this all will be 0. Minus cosine 2n pi divided by n square pi square. And minus, you will substitute the lower limit here 1. So 2 minus 1 is 1. So sine n pi x over n pi minus cosine, and you put here 1. So this will be cosine n pi divided by n square pi square. Again, you know the value cosine 2n pi will be 1 for all values of n. The reason is it will come every time, even if you put n here 1, so it will be cosine 2 pi. So cosine 2 pi is 1. If you put here n2, it will be cosine 4 pi. So cosine 4 pi, cosine 6 pi, 8 pi, so on. And so this will be 1 when so it means this will be 1. So minus 1 over n square pi square minus 2 minus so sine n pi, you know the value of sine n pi is 0 for any value of n, so this all will be 0. And cosine n pi, we already know this is minus 1 power n over n square pi square. So if you simplify this, so 1 minus 1 over n square pi square plus minus 1 minus into minus is plus, minus 1 power n over n square pi square. Again you can combine this, so this will be minus 1 plus minus 1 power n over n square pi square. Now you can substitute this, because uh, we have to, if you look here, we have to solve this actually. This was our an. So we will solve this separately. We solve this separately, and now I will substitute here value of this integral and then value of this integral. So I call this 1. So therefore your 1 will become like this. So an is equal to, this was your first part integral, this is your second part integral, and now again you can combine this. Now if you combine this, so this will be equal to, because this you can see the same, now minus 1 plus minus 1 power n, it is same, so this will be 2 time of minus 1 power n minus 1 over pi square n square. I hope this is clear. So now for you people, the homework is, so you have to find Bn yourself. So this is your homework. So Bn you have to find yourself. I said An and Bn is almost similar, only the difference is sine and cosine. If here is sine, so there will be cosine, or if there is cosine, there will be sine. So this you can solve easily. And still, if you have any question problem, we can discuss in Moodle live lecture. Now another example is, look at the function f of x is equal to 1 if x varies from 0 to pi, and minus 1 if x varies from pi to 2 pi. Now you can see here the range of x is from 0 to 2 pi, so x varies from 0 to 2 pi overall. So it means, what is your n? L, so your L will be 2 pi. So now again the question is, find the constant terms. Find the constant terms a naught, a1 and b1 in the Fourier series of this given function. Now here I did not ask question find an and bn. So I specify you have to find a1 and b1. So it mean you can I can ask question you have to find an, bn, or I can specify you have to find a1, b1, a2, b2, or a3, or a5, or a6, whatever. So first you can find an, and then at the end you can substitute n as 1, or from the beginning you can find a1. It's up to you. So now again, if we can find the value of a naught, so a naught, you know the formula 1 over L, 0 to L f of x dx. So your L is 2 pi, as I said before. So 0 to 2 pi f of x dx. Again your function from 0 to 2 pi is not given, so it is again piecewise defined function. So x varies from 0 to pi, so your f of x will be 1, and from pi to 2 pi it is minus 1. So we will break this integral. So 0 to pi it is function f of x is 1, and pi to 2 pi it is minus 1. Now you know the integration of 1 is x, integration of minus 1 it will be minus x, and again you can substitute upper limit, lower limit, and you can simplify this. So you will end up with 0. So your a naught is 0. Now an is this formula. So now we have to find a1. So what you can do, from the beginning you can take n1, or I said you can find an in general, and then at the end you can put n1. So you can solve this by two ways. First you can find an, and then at the end you can replace n with 1, or first you can replace here n1, and then you can solve. So if you replace n1 and take L as 2 pi and simplify, so this will be 2 over 2 pi. So this will be 0 to 2 pi f of x cosine 2 pi x over 2 pi dx. And because why? Because 2 pi n is 1. So that is why we have written 1 here. You can see 1, and your L is 2 pi. So this will be you simplify this, so it will be f of x cosine x dx. Now 0 to 2 pi, again we have to break this into two integral. So because your f of x varies from 0 to pi as 1, and from pi to 2 pi as minus 1. And now this you don't have to use integration by parts formula here, so you can directly solve this. Integration of cosine x, you know it is sine x, and integration of minus cosine x is sine x, and you can substitute the upper value and the lower value. You can simplify, and you will get a1 as 0. Similarly you can find bn, and you can replace, because we have to find b1, so you can replace n as 1, and you can put here, simplify this. So again you will end up with f of x sine x dx. So again f of x your varies from when it be 0 to 1, 0 to pi, your f of x 1, from pi to 2 pi your f of x minus 1. So again you can there is no need to use integration by parts formula, so you can write integration of sine x, which is minus sine x, and integration of sine x is cosine x. You can substitute the values and you can simplify this. You will end up with 4 over pi. So your b1 is 4 over pi. I hope lecture is clear. In exam we can ask even more easier question. Here both question I solved for piecewise defined function. You can see here again here your f of x when x varies from 0 to pi, 1 from pi to 2 pi. In exam maybe we will ask only question if your f of x is equal to 1 from 0 to pi, and that's all. I will not we will not give this second part. So then you have to solve only one integral. So this question I have solved in extreme case. These are the extreme cases. Otherwise in exam we will not ask maybe piecewise defined function. We can ask piecewise defined function, but we can ask even direct simple function, and then you have to find the constant terms a naught, a n, and b n. And again in exam we can instead of asking a n and b n, we can ask find a2, b2, or a5, b5, and then you can replace n with that number and you can solve. I hope today lecture is clear, but still if you find any question, any problem, so we can discuss in our coming lecture. So take care of yourself, stay at home, and stay safe. Assalamu alaikum.